Alright, so here's the video for 2.3, the task. We're going to look at the process of building a perfect square. We want to keep it perfect, so we want to keep it the same on both sides. That's what it's asking us to do. If we look at question number 1, it says, what is the area of a new square? Well, if our old side was equivalent to x, the area of that old figure would be x squared, because x by x is x squared. But it's telling us we have a new length, or a new side, that is x plus 3. If both sides are x plus 3, what would the area of the new square be, or how would we represent that? Really, we can't find it because we don't know what x is, but we would be able to represent that as x plus 3 squared. Whether you realize it or not, this right here is vertex form. Remember, vertex form, y equals a x plus or minus h squared plus k. A is 1, there is no k value. Then it's asking us to use this model, okay, or the pattern from problem 1. Well, this is what I want us to get used to. We've identified our larger square as x by x. We've expanded each side, and when we expand each side, we've expanded each side by 3 units, or x plus 3 on the left as they have it, and x plus 3 on the bottom as they have it. Now, we fill in all of the sections. X by x is x squared. X wide by 1 high is x, so that means all 6 of these would be x's. And then we would have 9 1 by 1 unit blocks. And basically what we're doing is breaking this up into 4 separate sections. 2 of those separate sections are equivalent to each other. And then finally we have a 4th section. So when we do that, we want to use both, and this is question number 2, use both the diagram and the equations that we created to show that x plus 3 squared and x squared plus 6x plus 9 are the same. And how are you going to do that? If you need to rewind this, once we find the area for each individual section, we add them together, and that gives us x squared plus 6x plus 9. Essentially, that's how we prove they're the same. Okay, so again, if you need to rewind that, make sure that's in a complete sentence. I'm looking for a complete sentence for that. Moving on, question number 3, it says for each of the following clip blocks, draw a diagram of the block and write 2 equivalent equations for the area. A block with a side length of x plus 2. We'll start with your original. What are we doing? Think about what you're doing. You're adding 2 units to each side. That's what it's telling me. So I added 2 to one side, 2 to the other. Bless you. I'm live in class in case you haven't figured it out. Okay? The rest of them are working. So here's my basic model. I added 2 to each side. If I add 2 to each side, what's my problem going to be? Well, I can have 2 expressions for this. I can have one where the area is equal to x plus 2 squared. And what's the other one? Well, find the area of all your other sides. X squared. This is x, this is x, this is x, this is x. If it was in the previous, it better be here. And then my focal is right here. So I get x squared plus 2 groups of 2x, which is 4x total, plus 4. What about a block with a side length of 1? Well, think about that. You create a block of side lengths 1. I'm expanding 1 on each side. This should be pretty easy. X plus 1, x plus 1, x squared. I have 1x on one side, 1x on the other, for a total of 2 x's, and then I have 1 single block. Or how else do I write that? The side length, x plus 1, squared. Do we notice any patterns based on these first 3 examples? Well, what you should notice, and this is a couple of things, there's always an x squared. Always has it in there. Why? Well, it's quadratic. It's always going to have one. Okay? Some other things might be, and you may have to pause this and rewrite this because I'm not going to write everything on the board. But some other things might be I have the same number of x's on either side of my block. I mean, there's a few other things we could notice. The fourth section, or what we call the fourth section here, is always a multiple of how we added to each side, 1 by 1, 2 by 2, and the other one it was 3 by 3. That tells me how much. And then we get to question number 6. Question number 6 says, we want to write two equivalent equations for the area of each square. So we want to describe what is happening here in question number 6. Okay, so let's describe what's happening. Well, first of all, relay back to your models. If this 4x is a total of both sides, that means I would have to have the same number for both sides. So x squared plus 2x's on one side, 2x's on the other, right? Okay, so maybe we need to create a model for this, just so we're correct. 2 on one side, 2 on the other. Okay, great. So when I do that, I basically took that 4 and divided it by 2. That's how I get 2 and 2. Well, again, focus on that fourth section. If I expand each side by 2, then this fourth section is going to be 2 by 2, which is 4. How do I get 4? Half of 4 is 2. 2 squared is equal to 4. It's not 2 times 2, it's 2 squared. Maybe it'll make a little bit more sense if we do b. Half of 6 squared. Half of 6 is 3. 3 squared is 9. 9 goes in the blank. Not 6 times 6. Not 6 times 2. Okay? Why would we divide 6 by 2 and then go ahead and multiply it by 2? It doesn't make sense. This 6 tells me I expanded 3 units on one side and I expanded 3 units on the other. So x plus 3. That means that this fourth section has to be 3 by 3 or 9 total units. Same with c. 8 divided by 2 squared. 4 squared equals 16. 12. 12 divided by 2 squared equals 6 squared, which is 36. That is what has to go in the blank. Having that middle term tells me how much I expand each side by. I can't emphasize that enough. And then finally, question 7. Sorry if it's kind of dark over there. Question 7 is asking us some notables. Okay? Question 7 basically says, what's the relationship of B and C? Well, how did we use B to find C? Right? I had a student in class earlier. I'm not going to pick on her right now. I so want to turn the camera over there, but I won't. Okay? Haven't had her sign a release form yet to be in the video, so you know how that goes. But basically, I don't want to say this and be wrong. And in fact, she was not wrong. We take half of B. So in order to find C, we take half of B and then we square that. Okay? Or square it. C is equivalent to half of B squared. So this is what we need to write. We need to take this and write it in a sentence. Right? We take half of B quote unquote B and square it. That's how we find C. Will this work if it's negative? Okay, well, will it work if it's negative? Come back over here and look at these two real quick. If I take and make this x squared minus 8, and I make this x squared minus 12, that means I'm going to take half of negative 8, which is negative 4. If I take negative 4 and square it, I get positive 16. If I take half of negative 12, I get negative 6. Half of negative 6 is positive 36. So the answer to that is yes. The reasoning is two negatives always make a positive. Okay? Always. Always happens that way. Think about it. Negative times a negative is positive. That's what you're doing when you're squaring a number. And then what about if b is odd? Okay, fair enough. What if b is odd? The example we just did in class. We said, hey, what if we had x squared plus 5x plus something. Okay, b is odd. Well, half of that 5 has to go to one side and half has to go to the other. So 5 divided by 2. That means 2.5 has to go to one side and 2.5 has to go to the other. What if I model that? 1, 2 on one side, 2 on the other. Yeah, notice I didn't make it a half. I didn't make it a half because this half is going to be represented by this other color here. Half on one side, half on the other. That means I have 1x squared, I have 2 on one side, and I have a half x on the one side, as well as the other I get 2 x's, and I also have a half x on the other. Think about it. 2.5 and 2.5 is 5. Okay, 2.5 and 2.5 is 5. So many of you are going to want to go through the process and say, okay, this is 2.5. I'm going to square 2.5 as instructed in class. Don't. You're making it harder for yourself if we have to do the reverse, which is I know this number, C, and I want to find B. So I'm just going to square it. I'm going to get 25 over 4, and that's going to be the number that goes in the blank. Yes, it's a decimal. It is a decimal, right? Don't worry so much about it being a decimal. Tomorrow we're going to go through and finish and do the reverse of this, which actually I'll just show you now, then I don't have to create another video tomorrow. What's the reverse of this? Well, the reverse of squaring is square rooting. That's the reverse. The reverse of division by 2 is multiply by 2. Stop and think about that a second. The reverse of squaring is square rooting. The reverse of division by 2 is multiply by 2. If I make this a decimal, and let's say it's 6.25, well, that means 6.25, I have to take the square root of it and multiply it by 2. I can't do that in my head. And this is the hard part that students will fall into. You're going to want to, oh, now I got to get out my calculator, now I got a bunch of extra work to do. Okay, fine, you do that, and I'm going to take 25 divided by 4, or the square root of that, and I'm going to say that's equivalent to 5 halves. And then I'm going to double 5 halves, and I'm going to get 5, which is what my answer is to begin with. So you're working on getting out your calculator and trying to find out the square root of 625, and I'm done. All right, so as much as you want to make it a decimal, don't. Know that it is, but as much as you want to make it a decimal, don't, because you're going to make it harder on yourself. And then the last thing I'm going to talk about is the example 7 through, which we did in class. We did 7 through 10, which some people are done already. Good for them. Be working on that. Again, make sure you show your work. So 7 through 10. 7 is x plus 5 times x plus 5. The directions clearly state. Multiply and circle your middle two terms. So multiply the first 2, I get x squared. Multiply the outer 2. Distribute that x to both terms. Plus 5x. Distribute 5 to x. Plus 5x. Distribute 5 to 5. Plus 25. Circling my middle terms before I combine my last 2 terms. There you go. And then the last one was 17, which is x squared plus 8x plus what? What goes in the blank? Again, show your work. Your work is very important. 8 divided by 2. And think about what you're doing. Think about what you're doing. We stated we take half the middle term. Half the middle term is 4. We have to square it. So show your work. 16. 16 is what goes in the blank. That's part A. Part B is write it as a product of squares. Well, gee, I know a product of squares looks like this, Mr. Wilson, but I don't know what number goes in the blank. Yes, you do. When you took half of that middle term, you found that out right here. And if you're showing your work sequentially, it should be pretty easy. Okay? Again, make sure you get your work done and make sure it's submitted on time.